solve for the first one. Okay, I can see in my numerator over here, I've got two bases, and these two bases look the same. And as soon as I have like bases being multiplied, I'm always going to do two things. The first one is I'm going to keep the base. Guys, the school that I teach at, if my kids walk into my class when we're doing exponents and they look me in the eye and they're like, ma'am, keep the base, I give them a sweet because they're doing the right thing. Okay, we always need to remember that what we're actually working with here is exponents. Base is very, very important. Okay, we need to make sure that we're always keeping the base. All right, so if I've got 5 and 5, I know that I have like bases that are being multiplied. So I'm going to keep my base and I'm going to add my exponents. Now I've got x plus x, that's going to give me 2x. Okay, all of this will be divided by, now I know that I'm going to want to divide with something that has the same base. So can anybody tell me how else can I write 25 so that it has a base of 5? Who's got any idea? Tell me in the chat. Yes, Ndiabo.
Ma'am, gonna be 5 to 8 to the exponent of 2x.
Good, 2. 5 to the power of 2, and then that x we're going to multiply together with the 2, so we're going to have 2x. And hey, presto changer, what do we notice? 5 to the power of 2x divided by 5 to the power of 2x is just going to give us 1, because anything divided by itself is going to give us 1. So my answer is going to be 1. My boss is like, ma'am, you're not making any sense. Yes, I am. 3 divided by 3 is equal to 1. 5 divided by 5 is equal to 1. X divided by x is equal to 1. Therefore, 5 to the power of 2x divided by 5 to the power of 2x is equal to 1. But if we had done it the other way, if we had gone like bases being divided, we were going to keep the base and subtract exponents. So I was going to have 5 to the power of 2x minus 2x, which would have given me 5 to the power of 0, and anything to the power of 0 is equal to 1. So we were going to end up in the same place either way. And that's why we end up in the same place, because anything divided by itself will always have the exponents minusing each other, and they'll give us exponents of 0. Okay. All right. So this is the first way to solve this. Okay. Now, the second way we could possibly solve a question like this is because we have a rule that says, I'm going to write it up here. If I have x to the power of 5 multiplied by y to the power of 5, I know that x and y have the exponent 5 in common. So I can actually rewrite this as x times y all to the power of 5. It means the same thing, because I can still take the 5 and multiply it back in, and I'm going to get the same answer. You guys get me? So I notice over here that my 5 has a power of x times a 5 with a power of x. So I can put them both in a bracket all to the same power, because they both have the same power. So I can rewrite this top part as 5 times 5 to the power of x, because they have x in common. The same way that these two had 5 in common, these two have x in common. So I can take that out as a common factor over 25x. Now I know that 5 times 5 is going to give me 25 on the top. So I'm going to end up with 25 to the power of x divided by 25 to the power of x. And look at that. We get back to the same thing. Anything divided by itself is going to equal to 1. Ta-da! Maths is amazing. We're doing incredible, amazing things. All right, both of these rules come into play quite a lot, especially this one that I just wrote here. It comes into play quite a lot in grade 11. They use it quite a lot. So I think you guys should familiarize yourselves with it. And if you want to impress your teacher, it's always nice to do this trick. Okay, you just need to make sure that both of the bases have the same exponent. So if this one was x plus 1, we would not be able to do this. The only reason we're able to do it is because they both only have a base of x. They both, so not a base, an exponent of x. And Shaden, I resent that comment. Maths is always amazing. It might be difficult. It might be difficult, but it is always amazing. It's even more amazing when we get the right answer. Yeah, that's my favorite part. The amazing part for me is when I get the right answer. Okay, right. So down
sorry,
here.
Teacher Coco. Oh,
yes.
Sorry. For 25 to the power of x divided by 25 to the power of x, wouldn't you lose marks if you didn't just say take one base minus the exponent and then you have 0 and then it equals 1? You won't.
No, you won't. You won't, because the rule is x divided by x is equal to 1. So even if you had x squared divided by x squared, they wouldn't penalize you for that because you notice the correlation. So 25 to the power of x divided by 25 to the power of x, they know that you can see that it's 1. It's not like we can't tell. So we'll understand that you understand the math behind it, and we will give full mark. Okay. No, thanks, Teacher Nels. That was a really good question. All right, over here, guys, down here, I know that I've got 2 to the power of x in brackets to the power of 3. Now, as soon as I see a bracket and an exponent, guys, I'm immediately going to take this exponent on the outside, and I'm going to multiply it with the exponent on the inside. So I'm going to end up with 2 to the power of 3 times x is 3x, multiplied by 2 to the power of x. Now, over here at the bottom, I've got an issue because I do not have an exponent that looks the same. So how can I rewrite 16 so that it has a base of 2, guys? Let me know. Remember, I think Teacher Jen did show you this, guys, this trick. If you're struggling to figure out how to write it as a product of its prime bases, you take the number into your calculator, you go 16 equals, and then you click shift and you click fact. Okay, and it'll factorize it for you. Madikiza, we're going to need something a little bit more than that. Remember, I need my base to be 2. So grab your scientific calculator, click 16 equals, shift fact, and that's it, Unati. That's exactly what I was looking for. I was looking for 2 to the power of 4. Don't forget that there was an x over there, so we need to multiply 4 times x. That's going to give us 4x. All right. Now on the top, I notice here, like bases are being multiplied. Therefore, I'm going to keep my base and I'm going to add exponents. 3x plus x will give me 4x over 2 to the power of 4x. And what do I notice, guys? Oh, Zudine can't hear me today. Zudine's like, ma'am, make a sound. I've been talking. So that's very weird for me to hear that from Zudine today. I have been talking. That's it. Trealboka and Puseletso's got the right answer. Look at this correlation over here, 25 to the power of x divided by 25 to the power of x. Same thing down here. 2 to the power of 4x divided by 2 to the power of 4x will also give us 1. Okay, now I want you guys to notice something. A lot of the times, our teachers will do this. Okay, our teachers will do this. They will go, cancel, cancel, because they're the same. Our teachers do this a lot, right? But please, guys, the answer is not 0, because if I cancel, cancel, most of you guys are thinking, oh, there's nothing left, therefore 0. No, 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 no. What we are actually doing is dividing. Even if we cancel, if we cross cancel, even when we cross cancel, what we're actually doing is taking the 2 at the top and the 2 at the bottom and dividing. 2 divided by 2 will give us 1. Okay, 2 to the power of 4x divided by 2 to the power of 4x will give us 1. So when we are multiplying and dividing, if you ever do have to cancel, cancel, that does not mean that it's 0. It's actually 1. There's a 1 in that spot. Okay, and Madikiza says, why did I write 2 to the power of 4? Because I can take 16, Madikiza, and I can rewrite it as 2 to the power of 4, so that I have the same base everywhere. Okay, 2 to the power of 4 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So I can rewrite 16 as 2 to the power of 4. All right.
Yeah.
Okay, excellent. Awesome. Oh, all right. We've got Veronica joining us, guys. Thank you, Puseleta, for making Veronica feel welcome. Love that. All right, guys, we are on lesson 8 of 8. My one is just like, yo, Veronica, yo. I love it. Okay. I love that. We're going to practice. And now things are starting to look a little bit shifty over here. Let's look at number 1. Number 1, you guys are probably being like, ma'am, yo, what? Hey, wat gaan aan vandaag? Okay, when we're solving for number 1, what do we need, guys? I'm going to ask this in the chat. Whenever we want to compare exponents, what do we always need? If I want to do something with the exponents, what do I know about my bases? No maza, like a whole boss. That's it. I need the same base. Okay, it doesn't always have to be the same base everywhere because there's no way 3 and 2 are going to become the same base. But I do know that I can rewrite 9 so that it has the same base as 3. And I can rewrite 4 so that it has the same base as 2. So I'm going to ask you guys to do that for me. Okay, I'm going to ask you to take 9 and rewrite it with a base of 3 and take 4 and rewrite it with a base of 2. Okay. And then tell me what that's going to look like. Yeah, okay, I know my bottom isn't going to change. Nothing over here is going to change. Multiplied by 2 to the power of 2. All right. Anybody got an answer for me for the top? Yes, Mawande.
For the top, right?
Yes.
It's brackets, open brackets, 3 to the power of 2.
Good, and then there's an A on the outside. Good. Multiplied by?
Yes, brackets A. Multiplied by open brackets 2 to the squared.
Good. 2 squared to the power of A minus 1. I love how you remember the brackets, Mawande, because they're very important, eh?
Yes, ma'am.
Excellent. Love it. Okay. And I'm going to tell everyone exactly why these brackets are so important. Okay. So every time I see a bracket with an exponent, I know that I need to multiply the exponent. So I'm going to have A times 2. So on the top over here, I'm going to keep my base, always keep my base, 3 to the power of 2A multiplied by. And the reason why these brackets are so important is that I have to multiply over here, bracket, and this, I have to multiply the whole of A minus 1 by 2. So basically what I have is this 2 multiplied by A minus 1. And when I see something like this, I need to remember, this is why I don't want you to skip the bracket step. I need you to remember that you need to distribute. If you can do it and remember to distribute without the bracket, sure. But this is what normally happens. Many people will do this. They'll go 2 to the power of 2A minus 1. And that's completely wrong. Okay, because what we need to do is distribute that 2 to both of them. That's it. That's what I was looking for in Tlantla. So this is going to be 2 times A, which is 2A, and then 2 times -1 is -2. Okay, if you can remember to do that without brackets, you can. However, it's so easy to make a mistake when you're moving fast. Okay, so I don't 100%. I don't 100% recommend it. Multiplied by 2 to the power of 2A. All right, now I have like bases being divided. So I'm going to keep my base, always keep my base, and I'm going to subtract my exponents. Now I want us to be very wary of something. I've got 3A, or 3 to the power of 2A minus, and then I'm also going to put this part in brackets. I know you guys are going to hate brackets after this. 2A minus 1. Okay. Who can explain to us, why did ma'am put that in brackets? Why did teacher Coco put all of that in brackets? Who knows? Anyone got any idea? Mawande, whole rock star. Why did I put that whole thing in brackets?
This was in a exponent rule. So the denominator goes up when it goes up into the numerator, it becomes positive.
That's
not
it.
negative.
Excellent. Okay, so it's not really about it going up, but if I have to multiply, I'm going to go a times 2, negative times 2a will give me negative 2a. And then what happens when I go negative times negative 1? What happens to that negative 1? It becomes
positive.
That's it. It becomes a positive one. Okay, so I need to make sure that I'm remembering all of that. The way you're explaining it makes perfect sense. If your teachers explained it to you that way, then go ahead and do it that way. But this makes a little bit more sense if we use the exponent rule. Okay.
Yeah.
Does that make
Okay.
sense? Excellent. Well done. Love that explanation. That's it, Mawande. That's exactly what I was looking for. And then I'm going to multiply this by 2 to the 2 to the power of 2a minus 2 minus 2a, because I'm taking the top minus the bottom, right? So this is going to give me 3 to the power of, okay, if I just quickly rearrange this, I know that that negative is going to turn to a positive, so I'm going to have 2a plus 1, negative a, and 2a minus 2a will give me 0, so I'll end up with 3 to the power of 1. It's not necessary for you to write the 1. It just puts me at ease. So I put it there, multiplied by, over here, I'm going to have 2a minus 2a will give me 0, and I will have 2 to the power of negative 2. But I know my teacher is going to say to me, you are not allowed to leave your answer with negative exponents. So, Ndiebo, what am I going to do with that negative exponent?
You're gonna divide.
Good, I'm going to divide, or as we call it, we flip it. If this thing was over 1, or if this whole thing was over 1, this negative bracket will flip, go to the bottom, and then my exponent will become positive. So technically what I will have here is 3 over 2 squared. Please don't forget the squared. I see all of you saying 3 over 2. Don't forget that there's a squared there as well. It was 2 to the power of negative 2. So now it becomes 2 to the power of positive 2. So my answer is technically 3 over 4. Okay. That's it. Yes, Shaden is correct. We are inverting. So that's good. All right. Good stuff. All right. I want you guys to have a look at number 2. Remember, if we can't see, okay, if we can't see like bases, then we need to change everything to the same base. And the easiest way to do it, if we can't see it, is to take these numbers, take 18, take 8, take 9, take 4, punch them in your calculator, one after the other. You're going to go 18 equals shift fact. Okay. And then 18 will give you some sort of understanding of what it needs to look like. 8 will, and 9 will, and 4 will. And then we can compare because our bases will look the same. All right. I'm seeing a lot of hands. What's up? Somebody's definitely unmuted out there. I hope we're all muting. Hi,
Ma'am, I wanted to ask why every time when I try to watch the recordings, the screen is blurry.
Oh, that's a settings thing. That's a settings thing. Okay. And this is completely a segue from our lesson. Okay. All right. You need to look for a button that looks like this. It looks something like that. It looks like a little, you know, those cogs that they use in machines, that thing.
Okay.
Yeah. This thing, and you need to change your resolution. You need to change your resolution, okay, to something higher, and then it won't be blurry anymore. Okay.
Okay. Okay. Thank you.
Thanks. Thanks, Philip. Shaden's like, ma'am, you can draw. Shaden, stop lying. Stop lying to people. Okay. Madigisa says the answer is 2 to the power of 4x minus 7 divided by 9. Madigisa, I can tell you now, we will not have any x's left in our answer. Okay, so we need to figure out exactly what's going on there. Okay, we need to make sure we're understanding what's happening. All right, okay, I'm going to try this one out and let's see what we get. I know that 18 is going to translate to 2 times, and let me not forget my one days brackets, 2 times 3 squared, all of this to the power of x. And now remember, if there's ever a number sitting on its own, it's always to the power of 1. Multiplied by brackets 2 to the power of 3 of x minus 1. That's why I love the brackets, so I don't forget to go 3x minus 3. It's not just 3x minus 1, okay? Over this 9 will be written as 3 squared, all to the power of x plus 1, multiplied by, and then my 4 will become 2 squared, all of this multiplied by 2x minus 1 at the top. All right, all to the power of, not multiplied, to the power of. Okay, so now I'm going to start distributing. I see a bracket and an exponent. I'm going to multiply. Over here, I see a bracket and an exponent. So I'm going to take this whole thing and multiply it by 3. Same thing over here, bracket exponent to 2, bracket exponent to 2. So we need to make sure that we are distributing all the way through. Okay, on the top, I'm going to get 2 to the power of x times 3 to the power of x times 3 to the power of 3x minus 3. Make sure I don't miss a single thing. Yes, Shaden.
Sorry, ma'am, I just have a quick question. Ma'am,
Yes.
do you think that in the exam they will like ask us, maybe, for instance, they give us a law, and that law is law 1, and then they give us the same base, then you obviously have to add the exponents. But do you think they will like give us something like that, and then they ask us which law that is?
No, never ever. Okay.
Oh.
The thing is, if you go to one school and the law that they put there in your school is law 1, what happens if at my school it's law 3?
Oh, okay.
Or
Because
in
I
another
do know
place?
that law 3 and 4 is almost the same because of the brackets.
Now, I don't know which laws those are, Shaden, because maybe
Okay,
at
okay.
you see what I
Okay,
mean?
sorry.
So we just learned the law. It doesn't matter what number it is. Okay, if the numbering works for your brain, use the numbering. But what we want to see is that you apply the law. You get what I mean? So you know how to use it. That makes
Yes,
sense.
ma'am.
Okay,
Yes, ma'am.
excellent.
There's
Yes.
only one law that I don't understand. I still don't get it, which is
Okay,
the
give
law
it to
with
me.
the
Give
negative
it-
exponents, ma'am. That one,
This
those
x to the
negative
power of negative
exponents.
4.
Oh
This
my
one.
word.
Oh, it's not that bad, and I'll show you.
No,
I'll show you why. We're going to do a quick question with it now. Okay.
Okay, ma'am. Thank you so much.
Excellent. All right. Don't stress too much. All right. No, Lwazi, I'm going to take your question. I just want to make sure I finish this question up quickly. Okay. So down here, I'm going to keep my base 3. And then this is going to be to the power of 2x plus 2.
I think you have 2 instead of 3.
Oh,
I mean, you
yes.
have 3 instead of 2.
Oh, thank you. Yes. Oh, you are a
Yeah.
whole rock star. This is 2. I shouldn't have written 3 there. Thank you, Kiforatile. Somebody's paying attention. I was testing you guys and you failed. The only person who passed was Kyo. I'm kidding. I also didn't notice. Thank you, Kiforatile. Okay. All right. Down over here, I've got 2 to the power of 2 times 2x will give me 4x times 2 to, oh, and then 2 times negative 1 will give me negative 2. And yeah, I was correct. We should not have any x's in our answer in the end. All right. So over here on the top, I've got 2 bases that are being multiplied to each other. So we're going to keep the base and add the exponents. Nomaza says, ma'am, is the answer 1/54? Let's see. I don't know yet. Me also, I don't know. Okay, I'm going to get 2 to the power of, I've got x plus 3x. That's going to give me 4x minus 3 multiplied by 3 to the power of x. And on the bottom, oh, I'm lying. This is 3 to the power of 2x. This should have been 2 to the power of 2x. So this is 3 to the power of 2x. Okay, then over here at the bottom, I'm going to take these 2 and I'm going to switch them around. just so that the 2 is sitting underneath the 2 and the 3 is sitting underneath the 3, if you guys know what I mean. So I'm going to have 2 to the power of 4x minus 2 multiplied by 3 to the power of 2x plus 2. All right, now Shaden, here comes that minus that we were talking about. Okay. Sorry. I'm doing such a great job today, guys. Okay. All right, so over here, I now see that like bases are being divided. So I'm going to keep my base. I'm going to keep my base 2, and I'm going to subtract. So I'm going to subtract the top. So I'm going to have 4x minus 3 minus 4x, and then I'm going to have minus negative 2, which will give me positive 2. Okay, I hope everybody was following. If I put a minus over here, this is going to become minus 4, and that's going to become plus 2. Okay, and that's where I get the plus 2 from. Okay, multiplied by 3 to the power of 2x minus 3 minus 2x, and then this positive 2 over here is going to become negative, minus 2x minus 2. Okay, and I'm going to have minus 2 over here. And this is going to give me 4x minus 4x will cancel. And then I've got negative 3 plus 2 will give me 2 to the power of negative 1. Veronica says, ma'am, are you doing expressions or exponents? We're using both of them together. Okay. It's going to give me 2 to the power of negative 1 multiplied by 3 to the power of 3 to the power of 2x minus 2x will give us 0. And then I've got negative 3 minus 2. And that's negative 5. Okay. So, Nomaza, I think your calculations were a little bit off. Just a little bit. Now, Shaden, here comes the problem. Both of my exponents are negative. And normally what we do is we do this. If I've got x to the power of negative 3 sitting on its own, just like that, I'm going to put it over 1. I'm going to put it over 1. And as Zudine said, we're going to invert. I'm going to take the 1 to the top and bring the x to the bottom. And then I'm just going to make the sign positive. So I'm going to take this whole thing, put it over 1. And then I'm going to invert them both because they're both negative. So this will equal 1 over 2 to the power of 1, which is just 2, multiplied by 3 to the power of 5. Okay. If you punch that into your calculator, it should be a really big number. Okay, 1 over 3 to the power of 5 is, what's 81 times 3? 244 times 2. 244 times 2 is 488. Okay, yes, no, Lwazi. Yes, ma'am.
Hey, ma'am, sorry,
Hi.
I'm late.
No worries.
At my school, we do trigonometry and exponents at the same time. So I'm failing. I do not understand the exponents very well. I do not understand the laws because when we're given examples, we're given examples of variables, not numbers. So now when you include numbers, I get really confused and lost.
Okay, all right. No, Lwazi, okay. You need, oh, yes, thank you, Lucia, for 486. All right. Thank you. All right, no, Lwazi, the thing to remember, the thing to remember is that when we have things like 3 to the power of x plus 1, right? What we're actually doing is we're using the maths that we learned in grade 8, the algebra that we learned in grade 8. I know that x and 1 are unlike terms. Yes? Are you with
Okay,
me?
Yes,
they're
I am.
unlike terms, so I can't add them together. I can't do anything with them. Okay, the only thing I can do is I can see if there's another 3 with an x that I can then add those two like terms together. But also we need to incorporate the idea that we are multiplying things that have the same base. Okay, so we need to do 2 things at the same time. Okay. It takes practice. Okay, it does take. Okay. Ooh, and that rooster in the back.
Yes.
is doing the most. All right. Nolwazi, my advice to you would be to do all the quizzes from last week and the quiz from this week, okay? Because they have a lot of the things that you need to know, okay?
Okay, ma'am, I'll do them.
And also rewatch the videos if you need to, okay?
Okay, ma'am.
All right,
Thank you.
excellent. You're very welcome, my sweetie. Muteo, what's up?
Hi, ma'am.
Hello, my sweetie.
Ma'am, where does that negative, the minus come from? From like when we like say negative 2x plus 2. Where does that come from?
This negative in front of it. So you mean
Like,
this one,
ma'am,
the one I wrote in blue, this one over here?
yes, ma'am.
If I have two bases that look the same, Mateo, and I'm dividing, what do? Like bases being divided, we keep the base and
No.
we,
Minus exponents.
good, 7 minus 2 would give me 4. So over here, I know that that is the base on the top, 4x minus 3, and I need to minus what we have on the bottom. That's technically what I'm doing. Okay, that's why I can say minus, because we are minusing.
Oh, okay.
You get me? So it's just that there's a big thing that we're minusing. It's not just one thing. It's 4x minus 2 that we are minusing. Okay?
Oh,
Excellent. All right, guys. All right, let's look at some of these rational exponents. Yeah, Madikiza, we need to remember the rules. Okay, they're very important. Okay. Yes, my sweetie.
Ma'am,
Yes.
on that step name, ma'am, now I did a different method.
Okay, what different method did we use here?
I on the last step, ma'am, I got 2 to the power of x minus 4 times 3 minus to the power of negative x minus 2 times 3 to the power of x times 2 to the power of 3x minus 3.
How did that happen? Okay.
I just changed.
Okay, Madikiza, are you still there? Oh no, I've lost him. Okay, I'm gonna have to wait for you to come back, Madikiza, because I'm not sure I'm understanding where you're coming from. Yeah. Oh, Letabo, unfortunately, we can't. We have all these videos. They're up on YouTube within 48 hours. Okay. Yo, not YouTube. Sorry, on our website. Yo, on our website. Only the old videos are available on our YouTube page. No, Maza, you know what? We just don't have time for those children's things now. Okay. We don't have time for the children's things, man. No worries, Owami. Hi, Madikiza. All right, everyone, while he explains, can we please try this one? Just give me a second, Madikiza. Guys, remember, I have a bracket and an exponent. So basically, all I need to do is distribute to the exponents. Okay, that's all. That's all we're doing. The exact same thing you've done before. Yes, Madikiza. Oh, no, now he's muted. Oh, no. Yes.
On the final step about 3 to the power of negative 2 times 2 to the power of 4x minus 7.
Where did the 7 come from? I'm very confused. Okay, were you following all the steps that I did? Do your steps look like my steps? No? And I've lost them again. Oh my goodness. Okay, so this, guys, is going to be 2 to the power of 4a squared. I can change 16 to the 2 to the power of 4a squared, 1 over 4. Now, most of your teachers will be like, no, calculator. Yeah, no. Guys, fractions are difficult for everyone, even some of us oldies. Okay. Punch this into your calculator. Remember, we've got a bracket and an exponent. Just go 4 times 1/4 and 4 times and 2 times 1/4, and then get an answer for your exponents. Let's not play around with these things forever and ever. And Debo, what's up? Okay, and Debo's not answering me. And Debo, when you can unmute, we'll have a conversation, you and I. Okay, so I'm going to get over here, 2 to the power of 1. Always keep the base. Always keep the base. I'm just saying, because we've got a bracket and an exponent, we need to multiply the exponents. So I'm going to get 2 to the power of 4 times 1/4 will give me 1. And then over here, I'll end up with a to the power of 2 times 2 times 1/4 will give me 1/2. Okay. And that's what I will end up with. I'm so sorry, Madikiza. Hopefully, we can have a conversation somewhere else. Oh, thank you, Teacher Nels. That's actually very helpful. All right. So guys, I want you to bear in mind here, okay, that everything that you do for rational exponents looks exactly the same as everything that you would do for the exponents we were just doing. The only difference is we multiply with a fraction, and we add fractions, and we minus fractions. Nothing is different at all. Nomaza, what's up?
So, ma'am, for question 3, what you did is you simplified it, I'm guessing, and then multiplied the fraction into the power of 4 and the power of 2.
Yes,
right?
so I took 16 and I made it 2 to the power of 4 because I can do that, yes. Mhm.
Okay.
And then I know that if I have a bracket and an exponent, I must take it and multiply the exponents of each of the bases.
Yeah.
Okay. So now I've got 4 times 1/4 will give me 1, and 2 times 4 will give me 1/2. And that's
okay. Oh, okay. No, never mind. Now it makes sense. Okay, thank you so much.
Are you seeing what I've done there? But I also kept my base. Don't forget my base.
You kept your base.
All right.
Okay.
Okay, now let's look at this next one here at the bottom. Okay, what do you guys think I'm going to do with this 4 over here? What am I going to do with this 4 before we even get started? What am I going to do with it? Yes, Aviwe. That's it, Pusile. So that's it. Yes.
Okay. Does the 2/1 stay like that?
The 1/2?
Yes.
Yes, you can. If you want to be a little more pedantic, I know that anything to the power of 1/2 is actually 2 square root of a. You can do that. I mean, I don't recommend it. Nobody's going to mark you down if you don't, you know, but if you want to, yes, you can. Okay. Because there isn't much else we can do with it. It's an a. We don't know the value of the number. Okay.
Okay, thank you.
All right, excellent. Okay. All right, sure, Madikiza, I don't know how you're getting an answer like 8 at all, because we need to remember what we're going to do with all of these exponents. That's it, Lesejo. Okay, I'm going to take this 4 over here, and I'm going to make it 2 to the power of 2, or 2 squared. So I'm going to have 2 squared, don't forget my brackets, x to the power of 3, all multiplied by 1/2, to the power of x to the power of -1/2. Now, Shaden, this one is for you. What am I going to do with this x to the power of -1/2? Where is it going? X to the power of -3. And think about this one that's sitting down here. If it's negative down here, what do I need to do with it in order to make it positive?
Ma'am, don't you put it over 1 or something like that?
I would in this case, but then I would just have 1 times x to the power of -3, which is kind of pointless. So what I can just do is I can just take it and put it at the bottom. Okay.
Okay.
And then what about this x to the power of -3? I will take it because it's negative over here. To make it positive, I'm going to take it to the top. Are you getting where I'm going with this? Or are you still a bit lost? Okay, just swap them around. Just swap them around. Okay, all we need to do is, if it's negative, guys, put it at the bottom. And if it's negative at the bottom, take it to the top. Okay. We just need to switch them around. Okay, now here comes the kicker. This, I have a bracket and an exponent. So I'm going to go 1/2 times 2 and 1/2 times 3. Okay, so don't be afraid of having exponents in your answer, guys. I mean, fractions in your exponents. It's fine. We're following the exact same mathematical rules. It won't kill you. A fraction won't kill us. But if we don't know how to add fractions, put them in your calculator. 2 times 1/2 will give me, keep my base, don't forget to keep your base, 2 to the power of 1. And then I'm going to keep my base x, and then I'm going to get 3 times 1/2 is going to give me 3/2 multiplied by, and then I'm going to take this x to the power of -3 and I'm going to bring it up to the top. So this will be multiplied by x to the power of 3 over, and then my x to the power -1/2 will go to the bottom. And I will get x to the power of 1/2. It will become positive when it comes to the bottom. Right. Now, I have my like bases. I've got x and x, my 2 like bases. So I'm going to end up with 2. Remember, the 2 must come with us. X to the power of, I now have to add my exponents. Like bases being multiplied, keep the base, add the exponents. I need to go 3 to the power of 2 plus 3. Okay. If you do a bit of quick maths, that's going to give me 9/2. Okay. Very quick maths, over x to the power of 1/2. Now, guys, I have like bases being divided. I have x and x being divided. So I'm going to keep my base and I'm going to subtract my exponents. So I will have 2 and then keep the base x. 9/2 minus 1/2 is equal to 2x to the power of 4. If you punch that into a calculator, you should get 4. Yes, Nomaza?
So, ma'am.
Yes.
Okay, so where is it? I'm so sorry. Oh, for the 2 to the power of 1, x to the power of 3/2.
Yes.
Wouldn't that addition at the top that's happening also affect the 2?
The addition.
Like, you see how you said we have the same basis for x and x, right? So, like, wouldn't it also affect the base of 2?
Why would it? Are 2 and x the same base?
Ma'am, so like for the 2x times x, right? My question is that, so seeing as 2x is one term,
Yes.
like, wouldn't it affect the 2 as well?
No matter what.
Unless we're only adding same bases.
Well, of course, 2x times 3x. What's my answer?
Ma'am?
2x times 3x.
2x times 3x. Ma'am, wouldn't you also add in the thingy? The 3x to the 2. Sorry, the 3 to the 2.
We're not adding.
Making it 6.
What's happening? What are we doing? We are
multiplying.
Good. So I've got 2 times 3 will give me
6.
Good. Now the only 2 bases that are the same is that one and that one, right?
Okay.
So I'm going to keep my base. The exponent here is 1 and the exponent here is 1. So my answer will be x to the power of
2.
That's all. The only reason I can't go 2 and 3 are somehow affected. No, they're not. They're just numbers. And at this point, I only have 2 on its own. It's just 2 on its own. So there's nothing I can do with it. It must just come along for the ride.
Okay.
Yeah.
Cool.
Okay, excellent. If they're not the same base, leave it, girl. It must just come along. That's
okay.
all. All right.
Period.
Period.
Yes.
Awesome. Awesome. All right. I hope we're all on the same page with this. All right. If you still want more of these, I can always give you guys extra work to work on, but we're going to have to look at exponential equations very quickly. Okay. Now, many of you guys have probably already done exponential equations. Okay. I need a value for x that's going to make the statement over here true. Remember, we spoke about equivalence, guys. If I say that 2 is equal to 2, that is only true if both sides look the same. If I wanted to say 2 plus 1 is equal to 2, that's false. What do I need to do? I need to add 1 on this side as well. So the only way I can get an equivalence is if everything on both sides looks 100% the same. So if I've got 2 to the power of x is equal to 2 to the power of 5, what does that tell me about the value of x? Therefore, x is equal to what? What does x need to equal to? Yes, Nomaza?
X needs to equal to 2.
I need them to look identical on both sides. So I've got a base of 2 and my exponent is x. So what must my exponent be so that this side and this side look exactly?
Oh, we're doing the one on top. I'm so sorry. It's 5. Sorry, ma'am. I was looking at the package at the bottom.
Good.
I'm so sorry.
It must be 5. X must be equal to 5. All right.
Okay.
My x is in my exponent this time, not on my base. All right.
Yes, ma'am.
Excellent. Okay. Love that you're so willing to put your hand up and answer my questions, guys. Nomaza is leadership at the moment. Right. Okay. Love to hear your voices. Now, one day you too, loving it. Okay. Now, what I'm trying to do, guys, is I'm trying to get both sides to look identical. They must look identical, or at least the equivalent must be identical. Okay, this left side must equal the right side. So look at number 1 over here. I've got 5 to the power of x is equal to 5 to the power of 2. Nomaza is finally getting it. What does x need to be for this equivalence number 1 to be true? Therefore, x must be equal to, tell me guys, tell me in the chat, x must be equal to, ooh, shift factor was a long time ago. X must be equal to 2. For this thing to be equal, facts. You guys are telling me facts. Look at number 2, everybody. Look at number 2. Yes, Nomaza?
Ma'am, x is going to equal to 3.
You know what? Easy things. Them easy
Nah.
things.
But then now I'm looking at number 3 and I'm like, ooh, jump scare.
Of course it's a jump scare. Of course it is. But let's think about this, Nomaza. How did you figure out that x needs to be equal to 3? It's because I can rewrite 27 as 3 to the power of x will equal to. I can write 27
3 to the
as
power of 3, ma'am.
3. And then I could see that x must be equal to 3. That's how we can see that they're equal, yes?
Yes.
So now look at the base I have down here. I've got a 9. I've got a 9. So how else
ma'am,
can
you factorize that.
Not
3.
factorize, we're not going to be able to.
Thingy, ma'am,
How-
simplify it. Sorry, simplify it. We're not there yet.
How else can I write 9? How else can I write
3
9?
to the power of 2, ma'am.
Good. So I've got 3 to the power of 2 to the power of 2.
And then you put that 2, yes.
Right. So these two things will multiply each other, and I will have 3 to the
4.
power of x is equal to 3 to the power of
4.
Therefore, x must be equal to
4.
2.
4, ma'am.
That's it. Do you see how we did that?
Yes,
Okay.
ma'am.
What is the connecting thing that's happening over here? What must we always have that's the same?
The base.
High five. Right. The bases must always look the same. Okay.
ma'am.
You got me.
Mm-hmm.
Excellent. Ah, loving it. Love it. Keep up to that energy. Like now look at number 4. See what needs to happen on both
2
sides.
to the power of 2, ma'am. And then you'd
On
have
the
x
left.
as an exponent. Yes.
That's it. And then you can figure it out from there. It's so easy. You can do it with your eyes closed.
You?
Okay, maybe not my eyes
Like
closed,
I-
but Yeah, you get my point. You get my point.
Yes, ma'am.
Awesome. All right. Nomaza gets it. Shaden is lost. I'm going to explain to Shaden while the rest of you try number 4 and number 5. Okay. I'm going to remind you guys for this one over here that anything to the power of 0 is equal to 1. Choose your anything. Choose your energy, your anything. Okay. All right. Shaden, where are you? Shaden, unmute for me, my sweetie. Let's talk about number 2. Oh, she's gone. All right, guys. So Nomaza has just said something very important. Okay. The only way I can compare two things is if they have the same base. Okay. That's okay, my sweetie. I need you to put your hand up so that I can unmute you. Okay. So this has a base of 5 and this has a base of 5. That's the only way we can.
Okay, ma'am. I'm listening.
Okay, I hear you. I've got you. All right. The only way I can compare two things is if they have the same base. Yes, a base of 5 and a base of 5. Now over here, I've got a base of 3. I need to then turn 27 to something with a base of 3. Yes.
Yes.
How else can I write 27 so that it has a base of 3? 3 to the power of?
You know what I was thinking, ma'am? Because in number 1, it also like the bases need to be the same. So I was maybe thinking you need to times 3 like by something to give you 27. That's what I was thinking.
And you can't shade it because this side, this isn't actually 3. This is 3 to the power of x. It's not the same thing.
Yes.
Okay. The only thing we can do is change just the one that's just the number. Okay. So now I'm going to change 27 to 3 to the power of 3, and therefore x must be equal to? The x's must be the same. So x will be equal to?
Is it 3, ma'am?
Yes, it's 3, because I need both sides to look exactly the same. Okay.
Okay.
You got me?
Okay, I got
So
you.
if x is 3, then I can replace this x over here with 3. Do both sides look the same?
Yes, ma'am.
So my x must be equal to 3. Got me?
Okay, ma'am. Okay, I got you.
All right, awesome.
Thank you.
Guys, thank you so much. I've got a rush because I've got another class. Please take a screenshot of everything that's left on the screen at the moment. Yes, absolutely. For number 5, x is equal to 0. For those of you who said x is equal to 0, you guys are whole OGs. Well done. Take a screenshot, everybody. I've got to go.